Okay guys, so in this video we're going to be talking about determining whether a relationship is a function or not. So first of all, let's define function. So a function is a relationship between input and output numbers based on an equation. In order for points to be a function, they must be either one-to-one or pass the vertical line test. So let's talk about first of all, what the heck does one-to-one even mean? So one-to-one means that the input number cannot cheat, and I put cheat in like quotations, on the output number. So if you could pretend as if like the input and the output number are in a relationship like boyfriend and girlfriend, then the input number cannot cheat. Now that being said, the input number typically has to do with the x, the output number typically has to do with the y. So we're going to jump into write some examples so you guys can see basically what it is and how to identify whether something is a function or not. So we have a bunch of points for example number one, and these points basically have an x and a y. So the first number is the x, second number is the y for every single point always. X, y, x, y, x, y, x, y. So you could graph this, but in this case we don't have to graph anything, we just have to say whether it's a function or not. So if you look at the input, which is the x, I'm going to go ahead and circle all the inputs, and then we have to ask ourselves, are any of them repeating? Well, no, none of them are repeating. Well, if none of them are repeating, are any of them cheating? Well, no, then if none of them are repeating, then they're not cheating. So it is a function. So we're going to say yes for the first part. So for the first example, example one, that's going to be a yes. Let's do a couple more examples. We'll do some off the table so you guys can see what that looks like. So example number two, is this a function? So let's check. So we look for the x's or the input. In this case, the input numbers are on the left hand side. Are any of them repeating? So in this case, we can see that the 9 and the 9 repeats. Then we have to ask ourselves, is the 9 cheating on its original partner? Well, the answer is yes. 9 is originally paired up with the 5, and then the 9 comes up with the 4, meaning that it is not one-to-one. It is actually cheating on its original partner. Therefore, it is not a function. So we can't have the x or the input cheat, or it's not a function. Okay, let's try number three, example 3. So we look at the x's. So the x's are circled, or the input is circled. We have 1, 2, 3, 4, 5. Are any of them repeating? Well, no, they're not. They're all different. Therefore, are any of them cheating? Well, no, they're not. Again, we're not looking at the y, even though we have y's that is a bunch of the same number. We don't really care about the y's. It's like saying like these people, they don't even come to our school. We don't really talk to them. Why do we care, right? So the only ones we actually care about are the inputs or the x's. They have to be one-to-one, and if they are, then it is a function. So in this case, the input is not cheating, so we say yes, it is a function. Example number 4. So we're going to go ahead and circle the inputs again. So let's circle all the inputs, and then we have to say, okay, is this relationship a function, yes or no? So if we look at the relationship, first of all, are any of them repeating? Well, yeah, the 4 is repeating here and there. So let's check real quick. Is the 4 cheating on the 8? So originally it's paired up with the 8, and then it pops up again. But wait, it is with the 8 still. So it's technically not cheating, right? It's still with the same partner. So we're good. So if you notice, negative 3 also repeats. So negative 3 repeats starting with the negative 2, and then it pops up again. But look, it's still with the same partner, right? So it pops up with the negative 2 originally, and then it pops up again with the negative 2, so we're good. If there is no cheating with the input numbers, then it is a function. So we're going to say yes for this one as well. Okay, now let's say you don't have any points or tables, and you want to figure out whether something is a function off of a graph. So the last thing we're going to be talking about is a vertical line test. So the vertical line test, what it is basically, it says that for a graph to be a function, a vertical line must only touch one time. So if it touches more than one time, it is considered not a function. And that applies for any vertical line. In any graph, it can be points, it could be a zigzag graph, or it can be a wave, whatever pops up. If you want to figure out whether something is a function or not, you have to use a vertical line test. So let's do a few examples of that, and then we are done. So example number 5, example number 6. So if we look at example number 5, vertical line means up and down, so straight up and down. It should only touch one time. So if I make a vertical line from top to bottom, anywhere on this graph, you have to ask yourself, is it only touching once, yes or no? If the answer is no, then it is not a function. If I make a vertical line here specifically, notice that it touches 1, 2, 3 times. So right off the bat, I know that it is not going to be a function because it touches more than once. So it touches here, it touches here, and it touches here. So that's going to be a hard no. Okay, if we do the same thing for g of x, in order for it to be a function, it has to touch only one time. No matter where we put the vertical line at, it actually only touches once, and you could actually verify this with your pencil, but I'm going to go ahead and just make one anyways, anywhere. And this is actually going to be a function because it only touches it one time. So if they give you a graph, you can use a vertical line test. If they don't give you a graph, you have to check whether the input is cheating on the output. Okay, so I hope this helps. Good luck. We'll see you guys in the next one.